because the technology is important, obviously. We want that to do the work for us for the most part. But the work being the heavy lifting of the mathematical crunching. Oh, Blink, very good. That book. What variable are we going to be testing? If we think we're underestimating an inch, what variable are we actually going to be testing? P or mu? We've got a gut feeling for mu. We've got a second for mu. We've got some, we're not sure. That's good. That's good. So think about the way I phrased the question. We're trying to, well, and the way we got the data. Think about that too. We're trying to see if we're underestimating 3 inches and 7 inches. Number one. Number two, how did you get the data that you just gave me? You measured it. You didn't count it. That's almost a dead giveaway when you're trying to figure out what data you're going to be crunching. If you count it, it's usually going to be a proportion, because you're counting something and then it's part of a total as a percentage. If you measure it, you're going to be dealing with an average. Like, I didn't say what proportion of you underestimated 7 inches or 3 inches. I said, are we on average underestimating? I didn't say the word on average. Hopefully it was implied. Are we on average underestimating 3 inches or 7 inches? Is that believable? Is that fair? Hopefully it's fair. Good. So yeah, we're going to test an average for the first time today. Yay. Makes me happy. It's a new, yes. Casey's here. He's even happier. So we're going to test an average. Right. And for this first one, let's put it, the camera's over here. For this first average, what's the definition of the variable going to be? It's a little bit weird because the data is a little contrived. I've got better data to look at here in a minute, like real data from a published study. But what average are we going to be testing? Go ahead, be brave, be brave. What are we interested in? Look back to the question over there in the box. Do we underestimate 3 inches or 7 inches? Go with 3 inches right now. So what average are we looking at?
Measurement we receive looking for 3.
Exactly. What you guys assume 3 inches is on average, right? It's what on average, and I mean you don't have to say that because it's right here. But it's what on average this class calls 3 inches. That's what the definition of the variable is. It's your data. We're going to be testing your data against the absolute value that the rulers gave us. Good. Cool. Now your hypotheses is what we're actually going to be testing. Which one of these can we believe more? Which one of these can we believe more? So can we believe null or the research? So I like doing the research first personally. I like having the research claim put out there because that's usually the first thing you guys think of, right? And what is our research claim?
We underestimate.
We underestimate, which means on average, our measurements that we give are going to be low. Give me a mathematical symbol, if you would. Less than. They're going to be less than 3. How much less than 3? The margin of error tells us how much less. Don't worry about that right now. We'll deal with that later. The null, therefore, if you want to put it in, which I think you should, is going to be either, now this is again where the journals might disagree with what you write here, and that's okay. The implication is that it's this, right? The opposite of underestimate is either nail exactly or overestimate. Very often they'll just put an equal sign there and call it good. But I'm still a math geek. I mean, I don't have stat degrees, I've got math degrees, and the math geek in me likes to see the trichotomy of all 3 things. Is that a question?
Oh, I was thinking about a quiz.
Oh, okay. Oh, okay, good for you. I saw the brow furrow. I know that, that's that. Good, all right. Okay, now this is where it gets a little silly as far as the errors, because nobody really cares about this. I mean, this is data for us right now to analyze to get the test done. Nobody really cares about, what this data. But what would the errors be in our test? I'm all hot to trot on errors too, because the last project that I'm almost done building for you guys is all about errors and power and things like that. So what would a type 1 error be in the context of this problem?
Saying we underestimate when we don't.
Saying that we underestimate when we actually don't. So in other words, we got some weird deviant data, but the population we're drawn from is actually just fine. We just got a deviant draw of data. Please, Rory.
Is the type 1 error always the same kind of, like it's always a false positive?
It always is a false positive, sir, yes. Yes, and because that, as one little final farewell to statistics, your last project, it revisits it again and again and again, although I never really let you not revisit it being in this class with me. But yes, false positive is always going to be a type 1 error. Thank you, Rory. How about type 2? What would type 2 be? I'm worried about this one with our data. I'm going to ask you why I might be worried about this right now in a moment.
Saying we don't underestimate what we actually do.
Very nice, Chris. That's your type 2, saying we don't underestimate when we actually do. So, Rory, give me a corollary to your last statement. What's a type 2 always going to be? Very good, sir. False negative. I am nervous about that potential in this test. If this were actual data we cared about, like if we were to publish it, I'm worried about a false negative, which means I'm worried about getting a negative test result. Can anybody think about why I'm nervous about getting a negative test result? It seems extraordinarily clear to me that we're underestimating, doesn't it? Those numbers are pretty low. They're all except for one under 3, and they're all except for one under 7. So why would I be worried about a negative test result? It's pretty clear that they're low, right? So it seems like they should be far enough left of where they should be.
Because of the sample size?
Because of the sample size. Go more, Brandon, go more.
That's all I got.
Oh, that's all you got? But why did you go to sample size, though? What are you thinking about?
Just, I mean, with the smaller sample size, the bigger your margin of error.
Which means even though what our average is far from 3 or far from 7, far is relative to how big a margin is, and the margin might actually gobble up both of them, which means they're indiscernible because of the sample size. Exactly, sir. That's why I'm a little nervous about a type 2 error, potentially a type 2 error. Because with such a small sample, your last project is called power. Power is a statistical measure. It's kind of like confidence. But it's, if you will, if you think of it this way, it's confidence to avoid a type 2 error. Whereas opposed to confidence is trying to avoid a type 1 error. Power tries to avoid a type 2 error. And when I get small sample sizes, you'll often hear this when you talk to people that are doing statistics in the field. We were worried because our study had low power. They'll often say, studies have low power. Their study has low power. What they usually mean is, their sample was too small. And that drove the margin so high that even though they got an extreme statistic, it didn't look extreme enough because the margin was so big on it that it gobbled up the null hypothesis, and therefore we couldn't tell a difference from it. So if you ever hear that in the biz, in your research as you go through your careers, that's what usually they're talking about, low power being small sample sizes. It's unfortunately a plague of small sample sizes is the assumption you have to deal with low power. We dealt with low power with the BP project you guys did last time around, the one that still hasn't been graded yet. Sorry about that, actually, by the way. There's some low power there. Sample size of 6, tiny, but it wasn't a hypothesis test. It was just trying to estimate how much oil was coming out. There was never a hypothesis being tested, so we don't have to worry about too much there. Good so far? You can skip the next question. It says which type is worse and why, because nobody cares, because we're measuring an inch and who cares. So you just give you a free point for that one. All right. One last question before I want to go back to the data. Which distribution are we going to be using? I vote for T. I vote for T. A second for T. All in favor? Chris says yes. All in favor of T? Any opposed? Discussion? Should the motion carry? I think we should discuss it a little bit. Just maybe 10 seconds. maybe 10 seconds of discussion. Why? Why would you, Brian, T? You said T right away.
Just because we're looking for the average.
Because we're talking about averages, yes? We're talking about averages. If we're talking about averages, we like to use the T distribution. Could we use a Z distribution? No, we shouldn't at all in this case because your sample size is so damn small. But even if it is, even if it was larger, I still would use a T because a T always works and it's a better, more precise measurement. Good, T distribution. So, I won't make us do this manually. I will not make us do this manually, but I want you to see what the black box is going to be kicking out for us. We need to get a test statistic and a p-value accompanied with that test statistic, right? And here's essentially, oh, Chris, please, go.
I missed the type of error that we could have. I mean, obviously, the only one we could have is the type
Oh,
1.
we don't know yet.
Oh, we don't know.
The reason I brought that up earlier, I said I'm concerned about a type 2 because I'm already predicting with these numbers we might get a big p-value
Right.
because I think the margin of error is going to be so wide, we're going to be shading a lot of the curve. That's just my gut feeling right now.
The only way to get a type 2 is before you start.
No. You're not going to know what type you could have made until we're done on the based on the size of the p-value.
Oh, okay.
You can try to avoid a type 2 or avoid a type 1 more by setting confidence at different levels. That's a different story. And again, the fact that you're asking this question makes me so happy that I'm writing this 4th project because it addresses that in great detail. Yeah, don't worry about that right now though, Fred.
Okay.
We don't know. You can't make both types of error after a hypothesis. You only make one. My fear is because this is such a small sample, we're gonna make a type 2. That's my fear. Just my fear. Now, a test statistic. A test statistic. Oh, Rory, go.
So we're gonna make a type 2 error because it's so small?
No, I don't know.
No, or because they're all like lower than.
See, that's the great question, by the way. That's the great balance. Since they're all so much lower than what they should be, that leads me to believe we're going to have a small p-value, which means we're going to believe this. Let's make sure we understand that line of logic right there. Since, looking at the data, these are almost all below 3 inches, correct? I mean, except for this one.
Yeah.
They're all below 3 inches. Which makes me look over here and go, well, it looks like we're on average lower than 3 inches. I think that's a fairly reasonable. But the problem is, because you guys are sample data, that means it has a margin of error. The margin, if the margin gets larger, our p-value is going to get larger.
Then that difference.
That's the problem, right? So the question is, yes, the data appears to be low, but there's not much data. So a low average combined with a small sample gives me a large margin, which makes me now question which one we're going to get. Big p-value means we're going to agree with this. Small p-value means we're going to agree with this. And I'm not even sure. I can't do the math in my head. You're about to see why I can't do the math in my head. Just FYI. Great question, Rory. Thank you. I always like coming back to that question. And please, if you ever have any paraphrase of that question, bring it up again. Because all we're going to be doing the rest of the term together is learning more and more tests. How to deal with different situations of data. But they all hinge upon which of these we believe more at the end of the day. So Chris, that's why I don't know what the error right now. But at the end of the day, we will. If we say this, we could have made a type 1. If we say this, we could have made a type 2. That's basically what the template will be. But we're not there yet. We have our conclusion yet. Good? Fair? Maybe. Getting there. Okay.
But we kind of went backwards here. We started with the data, and then we did this part.
And
So-
you know what's so funny? It seems backwards. But that's only because of the way most textbooks present hypothesis testing. They tell you which claim to test. They give you data and tell you which claim to test. I won't do that. I will always just look at the data and have you guys hypothesize what the data is showing us. So you guys, it was your guys' guess to go with less than 3. And I would have too, because it looks like it's less than 3. I came in today assuming that I couldn't tell. Historically, when I've done similar tests like this, asking students to estimate stuff, it's usually such a wide scatter above and below that it ends up being two-tailed, because I can't see in their data where the truth lies. But here, you guys pretty much all went down. There could be a correlation with the weather. I don't know. So that's the thing. You look at your data first and then go, oh, I wonder if this. Fair? Now, please realize, on your quizzes, I'll tell you which hypothesis to test. I don't want you having to make up your own hypothesis on a quiz, because you're still in the learning stage. And we're not together discussing it when you're doing the quizzes. So like in the quizzes for today, if you did it, I wanted to see specific hypotheses. Were the Bend AP pass rates actually lower? Did you actually do better on the quiz? So I gave you the hypotheses to test. In class, we'll develop them together as a class. That's why it seems backwards, probably, because you're comparing them to the quizzes. Fair? Good questions. Keep them coming. Actually, it's 9 o'clock. Don't keep them coming. Take 5. Go walk around and get some air. Look at the Catholic Church. Dude, this is so strange. This side of the class is almost full. There's like 5 people over here.
Why is that a Catholic church?
Well, because you notice there's a dichotomy in the seating, and I used to go to church all the time when I was younger. And nobody sit in front, they all sit in the back. And there was never a
You don't want to
symmetric.
get asked to do things.
What's
You
that?
don't want to get asked to do
Oh, maybe. That's possible. I was always an older boy, so I was up there anyway.